All right, in this problem we want to determine the intervals on which this function f of x equal to x minus 3 to the 2/5 power plus 2 is increasing and decreasing. So a function can change from increasing to decreasing or vice versa at its critical points. So the first thing we're going to do is find the derivative and then find the critical points. So if I bring the 2/5 down out front, by the chain and power rule, then I have x minus 3 still as my inside function to the power of 2/5 minus 1, or 2/5 minus 5/5 is negative 3/5, and the derivative of 2 is 0. Now we want to find where does this derivative, where is it undefined, and where does it equal 0. And I think it might help if we write it with a positive exponent for solving purposes. So I'm going to write this as 2 over 5 times x minus 3 to the positive 3/5. Now this does not exist where its denominator equals 0. So its denominator equals 0. You can probably just look at it and tell the value of x that will make that equal to 0, which is 3. Or you can work through it. So if you divide both sides by 5, then we have x minus 3 to the 3/5 equals 0 divided by 5 is 0. Then if we raise both sides to the 5/3 power, 0 to the 5/3 is still 0. That just means cubed root of 0 raised to the 5th power. So we get x minus 3 equals 0, or x equals 3. So that is a critical value or a critical point of this function. And we also need to see where does this derivative equal 0. So if I set this derivative equal to 0, I get this. And then to solve, we multiply both sides by this denominator right here. So on the left, 0 times that whole denominator is 0, and on the right they'll cancel, so I'll get 2, which is a false equation which has no solution. So that's saying that the derivative never equals 0. So our only critical value is that x equals 3. Now to tell if the function is increasing or decreasing before 3 or after 3, we need to put 3 on a number line and plug in a few test values into the function x minus 3 to the 2/5 plus 2. So I'm going to put 3 right here, and that breaks up my x-axis into the interval from negative infinity to 3 and the interval from 3 to positive infinity. And I want to plug some numbers into f prime of x. That's because by plugging into f prime, we can see if the value of f prime is positive, then the function's increasing, or if the value of f prime is negative, then the function is decreasing. So I'm going to plug into this version of f prime right there, and we need to just pick a test value in between negative infinity and 3. Anything in there will work. I'm going to go with like 0. So if I take f prime of 0, I'm going to have 2 over 5 times 0 minus 3 to the 3/5 is negative 3 to the 3/5. Okay, now the 5th root of a negative number is negative, and when you cube a negative number, it's still negative. So I have 2 divided by 5 times a negative number, which is going to be negative. So f prime is negative at 0, which means f prime is negative on the whole interval from negative infinity to 3, which tells us then that f of x is increasing on that interval from negative infinity to 3. Okay, doing the same thing over here. Let's plug in a number between 3 and infinity. So I'll go with 4 into the derivative. Gives me 2 over 5 times 4 minus 3 is 1 to the 3/5, and that's a positive number. So the derivative at 4 is greater than 0. So the derivative on the entire interval from 3 to infinity is positive. Oops, I said that backwards. When the derivative is negative, the function is decreasing. And when the derivative is positive, f of x is increasing. There we go. On the interval from 3 to infinity.